All right, this is recording attempt number 2. We had a camera breakdown and the whole thing got deleted off of OBS and there's nothing I can do about it. So I'm going to go ahead and re-explain these ones, but I only got one copy of these bad boys. So I'm going to have to, already have the work shown on the first 4 problems. And then what are you going to do? We're doing the functions test review, guys. How's it going? And what's going to happen here on these questions, it says each set of ordered pairs represents a relation. Determine if the relation is a function. So what you're going to do on all these questions is you only have to answer yes or no. On these yes or no questions, you got a 50-50 chance of just getting it right. You just got to answer one of the two. So at least take a guess, But what you're going to have to do, the reason why this one is a no is because we have an x value that is repeated, but they are different y values. So the rule is, again, saying it out loud here, if you have the same x must have same y. If your same x does not have the same y, then you are a no-go. So on this one over here, you have the same x. That -7 is repeated twice. However, once it goes to 4 and once it goes to -7. So because those are two different y values, the answer is no. Whereas on this question here, every single x value is already different. There are no x values in which there are the same exact number, and because of that, it is automatically a yes. The same exact idea happens on the next two questions, but this time your domain, these are your x's, and your range, these are your y's, are done with a mapping diagram. So on these ones, you're basically trying to figure out, do any of these x values go to two different y values? And because every single one of these x's has only a single arrow coming out of it, you have a yes right away. In the event that any of these x's had two arrows coming out of it, it would be a no unless both those arrows went to the same number. On this one, the same thing happens. We have no repeated arrows from an x value, and therefore we have another yes. Please note that it is not a problem that these x values both go to the same y value. That is okay, and that happens a lot on functions such as parabolas and absolute value. Let's go ahead and move on to the next page, where I actually am going to be starting off brand new. So we have each graph represents a relation. Determine if the relation is a function, then find the domain and range. So we're doing domain and range here. In order to do our situation, we got to figure out what is, first, if it's a function. To determine if it is a function or not, what we're going to be doing is what is called the vertical line test. So the vertical line test, what that says is, if any line drawn, any vertical line, so any up and down line, any vertical line drawn can only pass through one place, one coordinate. So on this question, if I drew any vertical line anywhere, we are totally good to go. So my answer is just straight up yes right away. Please note on both numbers 6 and 7, hilarious. We're going to go ahead and have a right away a no, because here the vertical line drawn would fail over and over and over again. And I'm going to pause real quick. Okay, I'm back. Yeah, I'm whining right now. I'm gonna whine. I've been trying to make this video since I got home like an hour and a half ago, and I've just been having issue after issue, and then I just get a phone call. I can't even do it. What are you gonna do? Anyways, we're talking about the vertical line test. We're saying any vertical line can draw and only pass through one place. This one fails a bunch because if I drew a vertical line here, it fails over and over and over and over again. So yeah, it's not gonna pass. This one's gonna be a no right away. And then this one over here, like I said, the 6-7 hilarious joke over here, we have another no right away. That's gonna be it, but this one over here will be a yes. So we have our simple yes and no's. We're done with that part. Now we're gonna move on to the part that people whine about the most: finding the domain and range. So how do you do these ones? What you're going to do, find domain and range. The domain is equivalent to saying, so I'm just going to write out the word domain here. The word domain is the possible inputs. So the possible inputs, aka the possible x's. So in this question, the possible x's are going to be that number here, -6, all the way to positive 6. Specifically, we can actually mark this coordinate right there, and we can actually say, hey, that coordinate is the coordinate negative 6 comma positive 2. Negative 6 comma 2. Likewise, on the very far end over here, this is the coordinate 6 comma 2 again. So what are the x values? The furthest left number and the furthest right number are negative 6 and positive 6, and therefore our domain we're going to write down is negative 6 less than or equal to x less than or equal to 6. So x is in between negative 6 and positive 6. Likewise, if you want to talk about the word range is the possible outputs. So our possible outputs, in other words, it is the y's. So on this one, if you notice, the y values are always 2. There's nothing else that y is allowed to be. So in this case, your range is simply y is equal to 2. There's nothing else that you're able to say, and we move on to our next question. On this problem over here, we are going to be interested in the highest point, the lowest point, the most left point, and the most right point. So over here, we have this coordinate on this side is going to be, let's look like negative 5 comma positive 3. So we got negative 5 comma positive 3. This one all the way down here, we're going to have 1 comma negative 6. That's this guy right there. And then we're also going to have this dot here is going to be 7 comma negative 1. This dot here is the exact same height as this one, so I don't need to write it again. So we're going to have 3 dots that we're interested in this question, and we need to, again, figure out the furthest left, the furthest right, the furthest down, the furthest up. So first, the left and right. The furthest left number on this graph is going to be negative 5. The furthest right number on this graph is going to be positive 7. So again, we're looking at that negative 5 here and that positive 7 here, and that's the furthest left or right it goes. I'm sorry that I wrote this in a different notation out of nowhere. You're supposed to say negative 5 less than or equal to x less than or equal to 7. Anyways, so we have that going on, and our range here is going to be the furthest down to the furthest up. The furthest down point is negative 6, and the furthest up point is positive 3. So we say negative 6 less than or equal to y less than or equal to 3. So if you're watching this video for the first time, you haven't ever used any of my videos, this is the first one that I've used for the school that I'm teaching at now. What you are supposed to be doing is attempting the questions on your own and then coming back and looking at it after you've already tried. So if you have not tried out questions number 7 and 8, where you're writing down those domains and ranges, you should go and attempt those first. And then afterwards, you will check to see what my answers were. That's my advice to you. So anyways, if you haven't paused and tried them on your own, you're not going to learn. So try on your own first, pause the video, try it, come back afterwards. Anyways, here's how we would do this one. On this one, we have arrows that go all the way up and all the way down. What that means is this graph continues off this edge and it continues on down off this edge. So there is going to be a furthest left dot. That furthest left dot is, looks like it's negative 2 comma negative 2 comma negative 2. So we do that furthest left dot, but there is no furthest up dot and there is no furthest down dot. It goes up forever and down forever, and it also goes right forever. So there's only this left-hand value we have to worry about. So for our domain, we are going to say that x is greater than or equal to negative 2 because it's either at negative 2 or it's on the right of it. So it's going to be bigger than negative 2. Whereas for our range, we are going to say that y is a real number, and we'll simply write all real numbers. So we can either write the words out, all real numbers. That is what many students prefer to do. But if you want to be slightly fancy, then you write this R with the double bars like that, and that's going to mean all real numbers. And specifically, you'd say y is an element of all real numbers. Over here on question number 8. So in question number 8, we have a similar idea. However, there is going to be a most left point. There's going to be a most top point. However, it will go down and to the right forever and ever and ever. So because of that, our domain here, we have to figure out what this dot is. This dot here is going to be, looks like -6 comma +1. The highest up dot appears to be right there, which is going to be 2 comma +5. And from here, we are going to go ahead and say that our x value has to be greater than -6. Please note how we didn't put the equal sign below because there is an open circle. There is a closed circle for this y though. So our domain for, or our range, sorry, for our y value is going to be y is less than or equal to 5 because it's 5 or smaller. Let's turn it to the next page here. On these questions here, on these ones, I'm going to highly, highly recommend a calculator. And because of that, I need to go grab a calculator really quick. Gonna pause. All right, we're back. So I haven't used my at-home calculator in such a long time that I had to plug it in to charge it. What do you know? All right, so we're going to go ahead and get going on this evaluate each function. So to start off on these questions, you need to show one step of work. And after you do one step of work, you're going to plug it into the calculator to get your final answer. Most of these questions are going to have decimals and fractions. That's going to be on purpose. You, again, are using the calculator for a reason. The calculator is going to help you get to that correct answer. If you want to do any of these by hand or in your head, you have fun doing that. We're going to do it on the calculator as practice here. So on all of these questions, what you're trying to do is figuring out what is the y value when x is a specific number. There are two different types of notations for this. There is the quote-unquote standard notation, also known as the Leibniz notation, and then there's also the function notation, also known as the Newtonian notation. So you need to know both. You need to work with both, and they both mean the exact same thing. It means plug in x, figure out what y is. Substitute for x, figure out what y is. So we're going to go ahead and have that x, have this x, and we're going to go ahead and replace. We have that x squared is going to become something else, and that x over here, 4 times x, will become something else. I recommend writing it like this as your first time. So you write down where these x's both turn into parentheses. After the x's are turned in parentheses, you turn them into the number you're interested in. So just for the very first one, I'm going to write it twice. I will not write it twice on any of the future questions. We got -4.1 squared plus 4 times -4.1. You need to have this line right here. So I'm going to grade this line. I need to make sure that you know how to plug this in and you know how to write it correctly. Common mistakes that students make. They put the negative on the outside by mistake. That'll be an incorrect answer when this one over here on number 12 will have a negative on the outside. So you got to make sure you're being careful with how you're writing your parentheses down. Other mistakes students make is they write the wrong negative sign in their calculator when they're writing it down, but you write it down exactly as it appears. This calculator is the fancier one. That's okay. Yours doesn't have to be fancy. Your calculator has exactly the same stuff. You type in a parentheses, you type the number in, and you make sure you use the small negative sign. The small negative sign makes a number negative. You only use the big negative sign over here on the right when you want to subtract two numbers. So on this one, we're doing -4.1 and the parentheses squared plus 4 multiplied by parentheses -4.1 and those parentheses, and then you hit the enter button and boom, we get an answer of 0.41. So we'd say that y is equal to 0.41. For that final answer, you need to go ahead and write it in a coordinate format. So -4.1 is your x and 0.41 is your y. And there you go. Let's check out the next one, question number 10. So on question number 10 here, we're doing the same exact thing. Everywhere that you see an x, you are instead writing a parentheses. And then after that, you are filling in the number that x is going to be. And in this case, you have 0. And again, this is said f of x equals this -2x minus 1, and you're finding f of 0. So I'm going to say that out loud. This is f of 0. That is how you say that. You say the word of in between there. So you're plugging in the word number 0 there. You're plugging in the number 0 right here. And -2 times 0 is 0. So this one we don't really need a calculator for. This one we can definitely do in our head. So we get our y value is -1, or in other words, we have 0, -1 as our final answer. Let's keep on moving on to question number 11. So on question number 11 here, you're plugging in that 1.3. I'm going to start doing these a little bit faster because it's exactly the same concept over and over and over again. The reason why I'm making you practice this so many times is the fact that it's very, very useful in terms of like your overall mathematics growth. This one's going to be positive 0.8. I need to take a pause for a drink of water. All right, we're back. We're happy times. We got our water. Let's keep going. So, anyways, we're gonna do this one over here. We got question number 12. Same exact concept. You are taking again that -3, the changing the x into a negative there. And I want to make sure we're actually recording here. We are. Sorry, I panicked that I wasn't. And then we had -3 squared minus 10 times -3 and then minus 25. I do not feel like attempting this one in my head over here. So we're typing it in exactly as it appears. We have a negative on the outside. We have a negative on the inside, a 3 ending squaring, and then minus 10 times -3. Notice how I use the big negative sign when I wanted to subtract the numbers, and I use the small negative sign when I was making a number negative. So over here, we're subtracting 25 again. So there we go. We have what we're plugging in there, and then you go ahead and hit enter. And if we did it right, we end up getting -4. Please note, just for your general understanding, in the event that you type in something like -3 squared, it's going to give you a negative number. Whereas if you give in -3, all of it squared, it will give you a positive number. And the reason why this is happening is because this version is doing -3 times 3, and this one is doing -3 times -3. So this one has one negative sign, and this one has two. Likewise, on this question, this actually has 3 negative signs. There's one negative on the outside, and there are actually 2 negatives here on the inside. So anyways, turns out this guy is -4, and our final answer then is there -3, -4. Beautiful. And on this one over here, I didn't even finish writing it. I was busy getting my water. You got 1.3, 0.8. Mr. Richards, get it together. Here we go. We're going on to question number 13. So question number 13, we're plugging in 27/5. So we do so. We're going to go ahead and say y is equal to -3, absolute value, parentheses, 27/5, end the parentheses, -2, and the absolute value plus 6. Please note the calculators that we have at school do not have an absolute value button. Because they don't have an absolute value button, you must do the things that are on the inside of the parentheses first. If you are lucky enough to have one of these calculators that I have right here, these do have an absolute value button. So if you have this calculator, you can just use the absolute value button. I'll show that in a minute. But what we need to do, in case you're using the calculators from school, we need to make sure that these ones, we know how to do it, just this part. So you're going to type in just the part that is inside the absolute value first. So you're going to be doing that. We're going to hit our parentheses, and then we have a fraction action here. So we have fraction. This calculator, I got to update this calculator. This calculator doesn't even have the new buttons over here. So we have to use the old buttons here to get to our fraction. So this calculator, you can see it wasn't even turned on. This doesn't have the most recent TI update. So this thing is at least, I don't know. I haven't used this thing in at least 5 or 6 years. Man, oh man. I don't know what's up. All right. Anyways, if you do 27/5 minus 2, you get 17/5. You can also do that in your head if you really, really wanted to. It's not hard to do. All you're doing is 5 times 2, which is 10, and 27 minus 10 is 17. So that's how the calculator is doing it. So you end up with the absolute value of 17/5 and then adding 6. Then you do the absolute value. The absolute value of 17/5 is 17/5, so it turns into parentheses. Please note, if it was a negative number, it would become positive because the absolute value of a negative is a positive number. After that, we start typing in as it appears. So -3 times 17/5. I forgot to get the fraction bar going. So 17/5, and then end those parentheses, and then plus 6. So we end up with this -21/5. Yet again, if you want to hear how you could do this in your head, 3 times 17 is 51, so -51 there, and 6 times 5 is 30, so -51 plus 30 is -21, and that's where you get that -21/5. And our final coordinate there is going to be 27 over 5, comma negative 21 over 5. And there you go. And again, if you do have this calculator, it will do that those absolute values for you. So we're going to go ahead and use the absolute value button. If you want to find the absolute value button in your calculator, the easiest way to find it is by hitting alpha window. If you hit the alpha button, this green button right here, and then the window button up there, so you're going to hit the alpha and then the window, and then absolute value is the number 1 up there. So you hit the absolute value, it shows up. So that's where you want to do it. To actually type in the entire thing, I'm just going to do it super fast, -3, and then alpha window, get that absolute value going. See if I can type this in quickly. We have our fraction here. We have 27 over 5, end the parentheses, -2, get outside the absolute value, add 6, and sure enough, you get that same answer, -21 over 5, even if you were just doing it all there. Let's move on to number 14. So number 14, same exact idea, 5, f of 5.4 end equals absolute value, parentheses, 5.4 end absolute value plus 2, end absolute value there, minus 4 equals 5.4 plus 2 is 7.4. So we end up with the absolute value of 7.4 minus 4, which is 7.4 minus 4, which is 3.4. So we get a final coordinate 5.4, comma 3.4. Beautiful and easy. Let's move on to question number 15. So on question number 15 here, we have negative x squared minus 2x plus 5, and we're plugging in negative 7 over 2. Be careful with all those fractions all over the place. Here we go. Negative 7 over 2 equals negative parentheses, negative 7 over 2 squared minus 2 parentheses, negative 7 over 2. If you are just copying right now and you are not trying the problems on your own, doing them for yourself, you are not learning. You should pause the video, try the questions on your own, and then afterwards, that's when you watch the video to see where you could have maybe made a mistake. So you're skipping around the video or not watching the whole thing just to do it. But, you know, if you are going to watch the whole thing, then well, whatever. What can I do? I can't complain. All right, so we're going to keep on going. We're going to plug this into our calculator. Again, way too lazy for me to actually do this by hand, so not going to happen today. Negative and then parentheses, get that fraction bar going there, and we got negative 7 over 2 and those parentheses, minus 2 parentheses, and another negative and another fraction and another 7 over 2. I forgot the squared. I'm going to go back and put it in there because it'll give me the wrong answer if I don't. So I got to go ahead and insert a square there. We did it. Beautiful. And turns out that's going to be negative 1 over 4. Interesting. The calculator took the parentheses away. I wonder why the calculator did that. I have not seen that before. Did I not put the parentheses? Is that my fault? No, the calculator just deletes it. Why didn't it delete the other parentheses? The world may never know. I'm going to have to look this up and figure out what's going on with these TI calculators, but for the moment, I don't care. The answer is negative 1 over 4, so we have this answer, negative 7 over 2, comma, negative 1 over 4. Let's move on to our next question. We're doing y is equal to negative x plus 2, negative 4x plus 2, sorry, and you're plugging in negative 1/3. So y is equal to negative 4, parentheses, negative 1 over 3, end parentheses, plus 2. This one, easy enough to do in your head. Negative 4 times negative 1/3 is 4/3. 4/3 plus 2 is the same thing as 4 plus 6 over 3. 4 plus 6 is 10 over 3. Beautiful. You get negative 1/3, comma, 10/3. Boom. Moving on to the next question. Our last absolute value question over here looks like. So we got f of 5 is equal to 3, absolute value, parentheses 5, minus 1, and those absolute values, minus 3. And out of sheer laziness, I'm just going to do this in my head. 5 minus 1 is 4. Absolute value of 4 is 4. 4 times 3 is 12. 12 minus 3 is 9, and we are doing 5, comma 9 as our final answer. By the way, this is the work that you need to get full credits on my test. It's written over a few times. You need this work in order to get that full credit. Let's move on to the next type of question. We're graphing. We're doing the big bad boys. Here we go. We're going to do these graphs. So when you're doing these graphs, what you have to do is you have to plug in numbers. Technically, on all of these questions, you have to do a version of guess and check the very first time that you're learning how to graph. And that's okay. We're simply making tables of values. We're not learning about any of these other fancy things. In the event that you go and look up how to graph things like this on maybe another YouTube video, maybe you watch a different one of my videos, maybe you watch somebody else, maybe you're going to Khan Academy, maybe you're asking a friend or a tutor or your parents or whoever, they're going to probably tell you that there's certain methods to graphing parabolas, certain methods to graphing these y equals mx plus b, certain ways to graph these absolute values. We are not trying to do that right now. We are going to do that later in the year. We're going to learn those methods. First, we're trying to figure out and playing a version of connect the dots. That's all we're doing. So in order to do that, we need to plug in numbers that quote unquote work. And you have to figure that out for yourself, which ones work. You are allowed to plug in any numbers that show up on the actual graph, and you're plugging in numbers like X. So -8, -7, -6, all these numbers you're allowed to try. Personal opinion. You should start off with 0 because 0 is very, very easy to begin your graphs with. Please note, if you want to feel fancy about questions that look like this, with a squared on them, the fanciness that I'll teach you is that you can always start by writing it as what is called -b over 2a. We learned that this is the location of the vertex of any of what is called a parabola. So you figure out in this problem that a is -1, b is -6, and c is -8. You do not need any of this for your actual stuff. So if you're just watching this video, you're supposed to be attempting it on your own first, plugging in a whole bunch of numbers. I'm showing you a trick if you feel like figuring out the easiest number to plug in without doing a bunch of guess and check. So we're going to be doing x is equal to -b over 2a. Where that comes from, again, we explore later in the year, not right now. It might even be Algebra 2 when we do it, but we're going to be plugging in our -6 where that b is. So negative of -6 divided by 2 multiplied by -1. So we end up with a +6 on the top and a 2 on a -2 on the bottom. So +6 over -2 is in fact -3. So we have that -3 value there, and that's going to be the easiest or a great starting point as where you want to plug in for these parabolas. If you use my advice from earlier, we used x is equal to 0. So those are the other ones that are good. So let's go ahead and make this table of values. When you're making this table of values, why did I write 0? It's supposed to be x and y. So x and y here, we are definitely going to be using our -3 here. And I'm going to go ahead and do kind of like this. I'm going to do a whole bunch of numbers here. So I'm going to put -3 here in the center. And then I'm going to do just other nearby dots. So nearby -3 will be -2 and -4. And just because I'm feeling fancy, we're going to use 0 because I told you earlier. And then, I don't know, arbitrarily, I'm going to choose also -5. So I skipped -1. You could also put -1 down and have a whole bunch of dots. The reason why I said 0 is easy because 0, if I have 0 and a 0, then it's just -8 right away. Let's go ahead and figure out what it is for -3. To make it figuring out for -3, you're doing y is equal to negative of -3 squared minus 6 times -3 minus 8. You are replacing these x's up here. You are making them -3s. Then you're, again, just like that previous page of you evaluating the functions, you are using your calculator as is appropriate. If you want to try to do these in your head, you can. Here's how you could. -3 squared is +9. There's a negative on the outside, so this is -9. Then -6 times -3 is +18. -9 plus +18 is +9. +9 minus 8 is 1. So in other words, you have the coordinate -3, 1. You'll repeat this process. This is a positive one, by the way. You'll repeat this process for every single value, the -2, the -4, the -5. Because I'm a math teacher, I know what the next two things are going to be showing up are. It turns out that this one's going to be 0. This one's also going to be 0. And that this one is going to be -3. If you want to try to figure out what the pattern is for all these parabolas, knock yourself out. I would love for you to try to figure out what the rule is, because if I gave you a hint, -1 over here is also going to be -3. Once you have 5 dots, you put your 5 dots on your graph. So 0, -8 is down here. -2, 0 is over here. -3, +1 is up here. -4, 0 is over here. And is that our 5 dots? 1, 2. Oh, no, -5, -3. -5, -3 is right here. And like I was saying, you'd also have -1, -3 if you wanted to. The other dot you could have figured out on this particular graph would have been -6, -8 if you wanted to know. So again, there's actually a rule that you could try to figure out for yourself. And if you are thinking about it, by the way, so you'd have like -6, -8. The next one after that is going to be -7, -15. So if you want to try to figure out what the rule is, please do. I'd love for you to try to feel like a math teacher, if only for a moment. Over here, we got the y = 2x + 6. This is actually our next unit in this class. We're going to learn how to graph questions that look like this every single time. But for now, we're going to go ahead and do our XY table. And like I said, I highly recommend starting off with 0. So we're going to start off with 0, and that's going to be our number in the middle. And we need 5 dots. I require 5 dots for every single graph. So we're starting off at 0 here. And then I recommend the next easiest numbers, which would be 1 and 2, and also -1 and -2. So going up there, plugging in 0, you get 6, because if I replace that x with a 0, 2 times 0 is 0, and adding 6, you get 6. Likewise, just like the previous problem, when you're plugging in other ones, you're doing f of, for instance, 1 would be equal to 2 times a 1 plus 6. Plug it into your calculator if needed, but you get 8, meaning that this guy is, in fact, an 8. Plugging in everything like this, you end up getting 10 here, you end up getting 4 here, you end up getting 2 here, and there you go. We have our dots that we're going to connect the dots with. We have our 0, 6, we have our 1, 8, we have the, is it -1, 4? Yes, and -2, 2. Yes, over here. And maybe you already know the rule. Maybe your previous teacher taught you what the rule is for these ones. But there we have our 5 dots. I'm a happy camper, and let's move on to our next question. So our next one, the last problem of this review, here we go. Y is equal to -x, x minus 5, absolute valued, -7. Holy moly, Mr. Richards, let's get it together here. So the trick to starting these ones, because I've been giving you the trick to all of these, yet again, you could plug in 0. Plugging in 0 will work out for you on this one. If you do plug in 0, let's just do that real quick, just so we can. Y is equal to, we're going to plug in again, 0, -5, and that absolute value, -7. If you do 0 - 5, you get -5. Absolute value of -5 is +5. -7, you get -2. So for our start of our XY table, you end up with a -2 at 0. So I'm just going to write, is that going to be a reasonable value? Yeah, it's fine. I'm just going to write 0, -2. There we go. First dot. After that, though, the actual best value to start off in these questions is whatever makes the inside of the absolute value 0. So you're going to say, hey, make this 0. Make this 0. If you make that a 0 on the inside, then you can figure out what the best number to plug in is. And that is going to make, so you're saying x minus 5 is 0, or in other words, x is equal to 5. If you plug in 5 there, you end up getting that 0 and you get -7. This is going to be the most important point on this graph. It's like the one that you really, really need in order to make sure you got the right answer. So yeah, that 5, -7. After that, there's a whole bunch of different correct dots that you could potentially already have. And just because these are the ones that I recommended, I'm also going to go ahead and do other similar values. So let's go ahead and do other ones that are nearby. So because of 5, I'm going to do ones that are nearby 5. So how about 6 and also 4? Those ones are nearby 5, so we can plug those in. If we plug in 6, you end up getting -6. And if you plug in 4, you also end up getting, what do you get if we plug in 4? Do we also get -6 there? For one more dot, I'm required to have one more dot for full credit in my own class. So I don't know, I'll plug in 2. How about a 2? We plug in 2 there, and we plug in 2. 2 minus 5 is -3. Absolute value of -3 is +3. 3 minus 7 is -4. Now we have 5 dots. We play connect the dots, and we are all done. 0, -2 down here. We have our 5, -7 down over here. We have our 6, -6. 6, -6 is right there. We have 4, -6. That's right here. And we have a 2, -4 is right here. And if you draw your graph correctly here, you end up with this V shape. Looks like this. All your absolute values are going to have that V shape going on. Anyways, we're all done with this one. Have a wonderful rest of your day, and peace out.